Hello and welcome. In this video, we're going to talk about functions and their graphs. And our learning objective in this video is that I can use function notation to represent and evaluate a function. So let's go ahead and jump right in. So before we really jump into this lesson, we're going to talk about function notation because the notation in and of itself can be really confusing. So we want to make sure we start out on the right foot. So what I want you to do is to look at each of the math sentences written on the left. See if in the column where it says English, you can actually write how you would say that out loud. If I said read number 5 and you were reading it, what you would say. And then in the last column, actually explain what it means you're going to do. It's okay if you don't know what all of them mean, but we want to just see where we're at before we jump in. All right, hopefully you've had time to do that. The first column, f of x or f of 2, which would mean that we're plugging in x or that we're plugging 2 in for all of the x's in the function f. F of x equals 2 means when does the function equal to? F of 2x minus 5 means that we're plugging 2x minus 5 in for all x's. G of f of x or g of f of 2. That's probably the most confusing to try and say out loud. Remember, with the composition of functions, we work from the inside out. So you would plug f of x into g or f of 2 into g. The next portion, f plus g of x, meaning we're adding the two functions, or f minus g of x, meaning we're subtracting. Similarly, f times g of x or f divided by g of x if we're multiplying or dividing. So pause the video and fill in anything you didn't get or add to what you already knew. Highlight anything that you want to make sure you remember later. And then let's go ahead and now actually look at problems that have this notation being used in it. All right, so here we're given the function f of x equals 3x minus 1, and we're given a table of values for g of x, and we're going to answer a bunch of different questions related to this. So for number 1, we're going to find f of 3, which means we're going to plug 3 into that function, and we're going to find f of x plus 1, meaning we're going to plug x plus 1 into that function. If you already have an idea how to do this, I encourage you to pause the video and try it on your own, and then unpause the video and see how you did. So if we plug in 3, then we're going to get 3 times 3 minus 1, so f of 3 is going to be 8. If we substitute in x plus 1, we're going to substitute that in for each x. Don't forget that we need to distribute that 3 to the x and the plus 1, so that's going to give us 3x plus 3 minus 1. And if we simplify, we're going to get that f of x plus 1 is equal to 3x plus 2. Let's look at another example. So here we're going to find f of g of 0 and g of f of 0. So for the first one, we're going to plug 0 into g first to figure out what g of 0 is, and then evaluate that in the function f. So to find g of 0, we need to use the table. Well, when x is 0, g is 5. So this is really the same thing as f of 5, since g of 0 is 5. And we can plug 5 into our function to get 15 minus 1, which is going to be 14. I'm going to encourage you to do this in the reverse order for number 2. So find f of 0 and figure out what g of that value is. So f of 0, if we plug in 0 is negative 1. G of negative 1 is 2. We can see that from our table. So we're going to rewrite what we were actually being asked. G of f of 0 is equal to 2. So for number 3, we're going to define a new function h to be x squared minus 1. And for number 4, we're going to use that function h. Number 3 is asking us when h of x is equal to f of x. So that's actually reviewing something from a previous section. I'm going to encourage you to pause the video and solve that, and then see if you can multiply the two functions together for number 4. Then unpause the video and see how you did. So if we set the two functions equal to each other, then we can solve by factoring out the greatest common factor and get the two x values, 0 and 3. Since we're not looking at graphs, we don't necessarily need to find the y coordinates, but if we did, we would just plug each of those values back into either of these functions so that we could write them as ordered pairs. Now to multiply the functions, we're really just going to use the FOIL method or the distributive method to multiply 3x minus 1 times x squared minus 1. So here we have those steps, and I'm going to go ahead and rewrite it in standard form. So we start with the highest degree for x and go down to the lowest. And there we have, let's throw an equal sign here. There we have the product of our two functions. I'm going to put two more examples up using these two functions, and I'm going to encourage you to pause the video and work through them on your own. So hopefully you had time to work through these two problems. Let me put their solutions up for you. So there's a solution for f minus h of x, and here is the solution for number 6. So the last thing I want to make sure we do in this video is actually the same type of problem, but if we were given a graph instead of being given a function or given a table of values for a function. So let's look at one last set of examples. All right, here we go. So you can see the graph of the function f, which is a piecewise function, and you can see that we're being asked a variety of different things on a through d. So go ahead and pause the video, see which of those 4, or maybe all of them, you can do on your own, and then unpause the video and see how you did. All right, f of 0 is simply asking us what is the value of the function when x is equal to 0, and we can see from the graph that the output is 2. For part B, what is happening at x equals -1? Well, at x equals -1, there is a vertical asymptote, which I'm going to abbreviate VA. For part C, we're being asked basically when the output of the function is 2. So I'm going to look at y equals 2, which is right around here. Oh, that was a little sloppy. But it looks like the function is 2 at x equals 0 and at x equals somewhere between 1 and 2. So I'm going to approximate that second value to be 5/3. And if I actually had the function, I could set the function equal to 2, but I don't know what that piece of the function is, so I'm going to use the graph to approximate. I'm actually going to say x is approximately 5/3 for f of x equal to 2. Last but not least, what's happening at y equals 0? Well, y equals 0 is the x-axis. And on the right-hand side, nothing special is happening over here. We're crossing the axes once, but on the left-hand side, the function is approaching the line y equals 0, so there's a horizontal asymptote, or HA, I'm going to use as an abbreviation, at y equals 0, and I'm going to just put in parentheses on the left-hand side of the function. And there we have some practice on reading graphs. So let's go ahead and recap what we have covered in this video. All right, so this section was about functions and function notation and their graphs, and our goal was that we can use function notation to represent and evaluate a function. Hopefully you are gaining confidence on that and you're feeling strong in your ability to evaluate a function. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.